Okay, let's now have a look at exercise again, 511, question 5E. So here we've got y equals x squared on x squared minus 4. And straight away, my first thing is, this looks like an even function. Let's find what f of minus x is. And that gives me minus x squared on minus x squared minus 4. And that gives me x squared on x squared minus 4, which equals f of x. Hence I get an even function. And I'm really happy about that because now I only have to graph half of it and reflect it in the y equals x. X equals 0, the y-axis. Now, again, let's find out what happens when x equals 0. Well, y will equal 0 on 0 minus 4, which is 0. So again, I've got the x and y intercept pretty quickly and pretty easily. What else do I need to know? Well, I also know, and I should have done this at the beginning, x squared cannot equal 4, which means x cannot equal plus or minus 2. So I've got two vertical asymptotes. Well, what about horizontal asymptotes? Now we know we have a horizontal asymptote when the limit as x approaches infinity of this function, which is x squared on x squared minus 4. And we'll divide by the highest power of x. So we've got the limit as x approaches infinity. We get x squared on x squared on x squared on x squared minus 4 on x squared. And that'll give me the limit of 1 on 1 minus 4 on x squared as x approaches infinity, which means I'm going to get 1 on top on 1, and as x approaches infinity, 4 on infinity approaches 0, which gives me 1 on 1. So I have a horizontal asymptote at y equals 1. So what am I going to do now? Well, let's put all the information I've got already onto the graph. So here we go. What do we know? Well, we know that y can't equal 1 and x can't equal plus or minus 2. We know we have the x and y intercept at 0 and 0. We know that's 2. We know that's minus 2. We know that's 1. And we know that it's an even function. But we need to be a bit better than this. So let's just look at the positive side. What happens as x approaches 2 from the negative side? Well, what will y approach? Well, let's put a number close to, but a little bit less than 2 into the function. So let's find out what happens when we have x equals 1.99. Well, I'll get y equals 1.99 squared over 1.99 squared minus 4. And if I go to my calculator, which I had down here before, here it is. Oh, come on up. So 1.99 squared divided by 1.99 squared minus 4 equals, negative 99, where'd you go? Negative 99.25. So it's approaching from this direction, negative infinity. I might just tidy that up. And we'll do it a bit better. So it's coming down here and approaching that. And we know it comes from that point. So it's looking like that. What about as x, so here, as x approaches 2 from the negative side, y approaches negative infinity. Well, what about as x approaches 2 from the positive side? What does y approach? Well, let's try and put x equals 2.01. And that means we're going to put y equals 2.01 squared over 2.01 squared minus 4. Well, let's get our calculator back and we'll clear all that. And let's try that. 2.01 squared divided by 2.01 squared minus 4, close the brackets. I get, let's get that back, 100.7. So it's approaching positive infinity. So if I go up here, and I know that that's happening. And I know from this previously that as x approaches infinity, that it's approaching 1. So as x gets really, really big, as x goes off into the distance here, I'm going to get that. Now, because I've already stated that it is an even function, I just now have to mirror all this. So I'm going to have that happening, and I'm going to have that happening. So all the tricks of the trade, all the things you need to know. And I didn't have to plot any points. I could have plotted some. The only ones I really got was 0, 0, and 1.99 and negative 99.25 and 2.01 and 100.7. But look at what I did. I found when the points of discontinuity for my vertical asymptotes, I found out that the function was even. I found when x equals 0, which happened to also give me when y equals 0. I found the horizontal asymptote by finding the limit as x approached infinity, and to find that I divided by the highest power x top and bottom, and I got a horizontal asymptote when y equals 1. And then I found out what happened as x approached 2, that's not negative 2, that's 2 from the negative side, so 1.99, and 2 from the positive side, so 2.01. And I found that x, when I approached from the negative side, was getting further and further down, negative 99. And I found that when x approached 2 from the positive side, it got closer and it got bigger and bigger. We got 100. So there we go. And you should be right to go and do a couple more.